As mentioned in the last video, direct recursion is the most common form of recursion. For this video, I want to go over tree recursion. Tree recursion is another specialized form of direct recursion. Unlike head, body, and tail recursion, tree recursions are non-linear. What is meant by linear recursion is when a recursive function calls itself one time. Tree recursions, on the other hand, are recursive functions that calls itself more than one time. Let's take a look at this tree recursion function example on the left. Notice how the recursive function is calling itself more than one time, and in this case, 2 times. Let's trace this tree recursion function in a stack frame. I went ahead and created an activation record for main. In the activation record, I am going to use TR as an abbreviation for tree recursion. On line 15, the tree recursion function with an argument of 10 is called. And every time a recursive function is called, a new activation record is created in our stack frame. So we enter our function on line 21, and the compiler checks on line 23 the condition of whether or not 10 is greater than 1. And in this case, this is a true statement. And since this is a true statement, we enter the if statement, where on line 25 we print the data. I'm going to use P to abbreviate print, and I'll write the output here. And so in this case, 10. We then make a recursive function call on line 26 where the data is cut in half. So 10 divided by 2 is 5, so TR5. Again, every time a recursive function is called, a new activation record is created. So we jump into the function again on line 21. And on line 23, the compiler checks the if condition. Is 5 greater than 1? And the answer is yes. And so on line 25, data is printed. The compiler then advances to line 23, where a recursive function is called, with data being divided by 2. So 5 divided by 2 is 2.5, but in integer division, the 5 is truncated, so TR2 is called. And every time a recursive function is called, a new activation record is created. We then go back to line 21 and enter the function. Is 2 greater than 1? That condition is true, and so we go to line 25 and data is printed. The compiler then advances to line 26. A recursive function is called. So 2 divided by 2 is 1, so TR1 is called. We then go back to the function on line 21, and the compiler advances to line 23, is 1 greater than 1, and that condition is false, and so the if statement will not be entered, and TR1 is popped off the stack frame. The control then goes back to TR2, and TR2 resumes on line 27, where another recursive function is called. 2 divided by 2 is 1, TR1, and every time a recursive function is called, an activation record is created. And so we then go back to the function on line 21, and then the compiler checks the condition on line 23, is 1 greater than 1, and the answer is no, so this condition is false. So TR1 is popped off the stack frame. The control then goes back to TR2, and when we go back to TR2, the function resumes after line 27, and there's nothing left to do in that function, and so TR2 is popped off the stack frame. The control then goes back to TR5, and TR5 resumes on line 27, and again 5 divided by 2 is 2.5, but since the decimal place is truncated, a recursive call for TR2 is made, and again every time a recursive call is made, an activation record is created. And so we enter the function one more time for TR2, and is 2 greater than 1? The answer is yes, and so data is printed. The compiler then advances to line 26, where a recursive function is called. So 2 divided by 2 is 1, so TR1 is called, and again a new activation record is created for TR1. So we enter the function, and on line 23 the compiler checks the condition, is 1 greater than 1? That is a false condition, and so the if statement is never entered, and TR1 is popped off the stack. We then go back to TR2, and TR2 resumes on line 27, and again on line 27 a recursive function is called. 2 divided by 2, again TR1 is called, and an activation record is created for TR1. We go to line 21 again and enter the function. It's 1 greater than 1, and that is a false statement, and so TR1 is popped off the stack. The control then goes back to TR2, and TR2 resumes on line 28, and there is nothing left to do in this function, so TR2 is completed and TR2 is popped off the stack. The control then goes back to TR5, and TR5 resumes on line 28, and there is nothing left to be done, so TR5 is completed and TR5 is popped off the stack. The control then returns to TR10, and TR10 resumes on line 27, where a recursive function is called, and so 10 divided by 2 gives us 5, so TR5 is called. And every time a recursive function is called, an activation record is created. We enter the function on line 21, and the compiler checks on line 23 if 5 is greater than 1. That is a true statement. And so we enter the if statement, and on line 25 the data is printed. The compiler then advances to line 26, where 5 is divided by 2, and again that gives us 2.5, but with truncation TR2 is called. So we enter the function on line 21 again, or so we go to the function on line 21. The compiler checks is 2 greater than 1, and the answer is yes, and so data is printed on line 25. We then go to line 26, where a recursive function is called. 2 divided by 2 is 1, so TR1 is called, and an activation record is created for TR1. We go to line 21 and enter the function, and on line 23 the compiler checks if 1 is greater than 1. That condition is false, and so this function is executed and TR1 is popped off the stack. The control then goes back to TR2, and TR2 resumes on line 27. 2 divided by 2 is 1, so TR1 is called again, and again an activation record for TR1 is created. Again we go back to the function on line 21 and enter the function. It's 1 greater than 1. That condition is false. There's nothing left to be done with that function, and so TR1 is popped off the stack frame. The control then returns to TR2, and TR2 resumes on line 28, and there's nothing left to be done, so that function is completed, so TR2 is popped off. The control then goes back to TR5, and TR5 resumes on line 27, where 5 divided by 2 is 2.5, but with truncation of the decimal value, TR2 is called. A stack frame is created for TR2, and we enter the function on line 21, and on line 23 the compiler checks if 2 is greater than 1, and the answer is yes, so on line 25 data is printed. We then go to line 26, and a recursive function is made for 2 divided by 2, which is 1, so TR1 is made. An activation record is created for TR1. Again, we enter line 21, and on line 23, the compiler checks to see if 1 is greater than 1. That condition is false, and so this function is terminated, and TR1 is popped off the stack frame. The control then goes back to TR2, and TR2 resumes on line 27, where a recursive function is made. 2 divided by 2 is 1, so TR1 is called. An activation record for TR1 is created. The compiler then goes to line 21 and checks the condition on line 23. Is 1 greater than 1? The answer is false. TR1 is then popped off the stack frame. The control then goes back to TR2. Well, TR2 resumes on line 28, and there is nothing else going on after line 28, so TR2 is completed, and so TR2 is popped off the list. The control then goes back to TR5, and TR5 resumes on line 28, and there is nothing going on after line 28, so the function is then completed, so TR5 is then popped off the stack frame. The control then goes back to TR10, and TR10 resumes on line 28, and again nothing else is going on, so the function is completed, and TR10 is popped off the stack frame. And once TR10 is popped off the stack frame, the control goes back to main. Our output should be 10, 5, 2, 2, 5, 2, 2. So let me compile this and check our output. So 10, 5, 2, 2, 5, 2, 2. Now let's trace this function using a tree. And again, I'm going to use TR to abbreviate tree recursion. So on line 15, the tree recursion function is called with an argument of 10. And so we go into the function on line 21, And on line 23, the compiler checks if the data is greater than 1. So it's 10 greater than 1, that is a true statement. And so 10 will be printed. And then on line 26, a recursive call will be made, which divides 10 into 2. So 10 divided by 2, we get 5. So I'm going to do it this way. And again, we go back to line 21, and the compiler goes down to line 23 and checks, is 5 greater than 1? Well, that is a true statement. So 5 is printed. And on line 26, a recursive function is called. And 5 divided by 2 is 2.5, but since the decimal place is truncated, we get TS2. And then we go back to the line 21 again. Is 2 greater than 1 on line 23? And that is a true condition. And so the data is printed, so 2 is printed. And let me circle the data that are being printed. The compiler then advances to line 26, and another recursive function is called. And this time with 2 being divided by 2, so that will give us TR1. And I actually meant to say that I was going to abbreviate tree recursion with TR and not TS. I don't know where TS came from. So I'm going to change all the TS to TRs. So there, much better. So now TR1 is called, and so we go into line 21 and enter the function, and the compiler evaluates line 23 is 1 greater than 1. No, this if condition is skipped and there's nothing left to do, and so the function terminates. The control is then returned back to TR2, and so TR2 resumes on line 27, where another recursion call is made. 2 divided by 2 is TR1. Again, we go back to line 21 and we go to line 23. The compiler evaluates is 1 greater than 1. The answer is no. So TR1 terminates. Control goes back to TR2. TR2 resumes on line 28 and there's nothing left to do. And so TR2 terminates and the control goes back to TR5. TR5 resumes where it left off on line 27 and a recursion call is made. And that recursion call is 5 divided by 2 is 2.5. And again, the 0.5 is truncated because of integer division. So a call for TR2 is made. Well, we already know what TR2 looks like. It looks like this on the left-hand side. We go to line 23. It's 2 greater than 1. The answer is yes. So 2 is printed. But if you look at this on the left-hand side, TR1 is called twice. And then the control goes back to TR5. TR5 resumes on line 28 where everything is done. The control then goes back to TR10 and TR10 resumes on line 27 where it left off. And a tree recursion is called for TR5. And again, this TR5 is going to mirror the left-hand side of the tree. So 5 will be printed here, and then you'll have 2 TR2s, and 2 will be printed. And then you'll have another TR2. 2 will be printed. And then from TR2, you'll have 2 TR1s. And since the TR1s are our exit condition, this is where the recursive function terminates. And this is what our tree looks like for our tree recursion. So now let's trace it using a different color. And let me put the output right on this side. And so we start on the left-hand side. And so we enter TR10, and 10 is printed. And then we go down, enter TR5, and 5 is printed. We go down and enter TR2, and 2 is printed. We go down and we go to TR1, nothing going on with TR1. So we go back, and then we go to TR1, nothing is going back. Nothing is happening with TR1, so we go back to TR2, and then we go to TR2, 2 is printed. And then we go down to TR1, nothing is happening. We go down. This is where our exit condition, so nothing is happening with TR1. And then we go back up, back to TR5. And then we go to TR5 and 5 is printed. And then we go down and to TR2 and 2 is printed. And then we go down to TR1, nothing is happening. We go back. TR1 again, nothing is happening. We go back. And then we go to TR2 where 2 is printed. So we go down to TR1 and nothing is happening. And then we go back up to TR1 again, nothing is happening. To TR5, back to TR10. And so this is our output 10, 5, 2, 2, 5, 2, 2. And let me run it again just to see if I traced it correctly. And there it is, 10, 5, 2, 2, 5, 2, 2. Now let's evaluate this tree. Let me erase all of the red marks on it so that we can examine this tree. So I want to highlight all of the function calls, or all of the times the function was invoked. So the function invocations, as my professors would say in college. The height of a tree can be categorized in levels. So the original function call, since it's the root of the tree, can be categorized as level 0. And then this next level would be level 1. This would be level 2. And then this would be level 3. So if you look at it, on level 0, we invoked the function one time, or we called it one time. On level 1, we invoked it 2 times. Level 2, we invoked it 1, 2, 3, 4 times. And on level 3, we invoked it 1, 2, 3, 4, 5, 6, 7, 8 times. So what pattern can we see out of that? Well, if I did this, 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, and 2 to the 3 is 8. So what this tells us is, as far as time complexity, it would be O of 2 of n. And as far as space, it would be O of n. So in summary, the height of the recursion tree is equal to the number of levels in the tree. And unlike a linear recursion, which calls itself only one time, the recursive function in the tree recursion calls itself more than one time. Thank you for watching.